Prisms and Cylinders, page 77 and 78 in your table of contents. Okay, I've already cut mine out, so you'll do this when I come back to your class on this page 77, surface area prisms and cylinders. On this one we have two theorems. The first one is the surface area of right prisms. Remember, with prisms, these sides will be rectangles so you can understand which are the bases. So the sides will always be rectangles. So the base will always be the other shape that is with the prism. And the formula for surface area is written here, that the surface area is 2b plus ph, or you could have the shortened version here of AP plus ph if you understand it. Remember, the A is the apothem. Remember that apothem is from the center of your shape to the side perpendicular. So if I was looking at the triangle on the side, it'd be right here in the middle of the B down to a side at a right angle. That would represent your apothem. The capital B, remember the capital is the area of the base, P was the perimeter, and of course H was the height. We're going to be using these theorems, or these formulas, in just a minute. The theorem 12.3 is surface areas of right cylinders, and the formula for it, if you look at it, you could have 2b plus ch, where c is the circumference, or you can use this other formula that I use all the time right here. This is the main one that I reference for cylinders. 2 times pi r squared, which is the circumference, or actually is the area of the circle, plus 2 pi r, which is the circumference, times h. Alright, on example 1, here I am given a prism in my problem. So that means I'm referencing the first formula that was S equals 2b plus ph. So that means I need to find the area of the base for my capital B. The base, remember, the sides for a prism will be rectangles. So if I'm looking at this, the rectangles are on the sides, kind of looks like a tent. The triangles on the ends is the base. So if I look at that triangle, realize it's a 6 by 6 by 6, so it's equilateral. If I drop a line straight down, it cuts the bottom in half, which gives me a 3 on one side. I need to find the height of that triangle so that I can use the formula for a triangle. The B can be versatile based on your base. So on this one, because it's a triangle, I'm dealing with BH divided by 2 for my area. This H I need to find. This is a right triangle, so I can use Pythagorean theorem to find the H, or I can use special right triangles. Because it's equilateral, that means each angle is a 60, and this top one cuts into a 30-degree angle. Since I know that this is X for the special rights, this side is equal to 2x, and the long leg here is x square roots of 3. Since I know x is 3, that means my height okay, I'm going to fill in my formula here so you can see it. I'm going to have 2 times the area of my bases, so that's going to be little b h divided by 2 plus the perimeter times the height, so that my h here in this formula is going to be 3 square roots of 3. Okay, I need to know the area, or the length of the base, which I know the B is 6, plus the perimeter of my base. Well, that was 6 by 6 by 6 all the way around. That means that is 18. And this height here, make sure you understand this height, sometimes it's confusing, is the height of your prism, not the base. Okay, the height of the prism. This is not the same h that is here. This is the height of your base. This is the height of your prism. The height of the prism is the other number that they give you in your pictures between your bases. That's the 8 that they have on this formula. Now, if I do the parentheses here, 6 times 3 square root is 3, and then I divide it by 2, you end up with a terrible decimal, but I would have 2 times basically 7.7942, and it goes on and on and on. Keep that in your calculator. Okay? Because now I'm going to take that number and multiply it times 2. I get a 15.588, and it goes on and on and on in my calculator. So I want to add to it 18 times 8. So I want to add 18 times 8. So it's all in my calculator. Let me turn on the light so you can see it. So I have all that in my calculator, and I have 159.6. And this would be inches squared. Alright, if I go to the second problem here, this is dealing with a cylinder. With the cylinder, I'm going to be using the pi r squared plus 2 pi r h, that formula for a cylinder. I'm going to rewrite it down here. And if I look at my picture, notice they have a 4, which represents my radius, and the 5 is modeling the interior length, which that means that is my h for my problem. So I'm going to take those two numbers and plug them into their appropriate slots. So that'll be 2 times pi times the r squared plus 2 pi times 4 and times 5. That will be my surface area. And I'm going to type this whole thing in my calculator and get an answer. Okay, so you can see it there. Let me turn the light back on. You can see it. And it's all in my calculator. And then I'll just push enter and I'll get my answer of 226.2. And the units is meters squared is my surface area. Okay, I turn my page and I'm going to go to example 3. On example 3, it says, okay, find the height of the right cylinder shown, which has a surface area of 198.8 square millimeters. So they're giving you the answer. This is still the cylinder, so the formula is still this 2 pi r squared plus 2 pi r h. Okay, if I look at example 3 here, it has a cylinder given to us, and they tell us the surface area is 198.8 square millimeters, and here's the formula we're looking at. And in the diagram, they give you that the radius is 2.8 millimeters. So if I start filling in this formula, I'm going to have 198.8 is equal to 2 pi times 8.2 squared, I'm sorry, 2.8 squared, plus 2 pi times 2.8 h. So I'm going to simplify this first part of my equation, and I'm going to type in 2 times 2.8 squared, and see that this comes out to 15.68 pi plus, and then I'm going to 2 times 2.8 and come out with 5.6 h here And this is still equal to 198.8. Oh. Let me stick my pi in there, and then an h. Now I'm going to subtract 15.68 pi from this 198. And my calculator, and that gives me 149.539, on and on and on and on. Keep that in your calculator. It equals 5.6 pi h. To get h by itself, I'm going to actually divide this by 5.6 pi. Now, it's on bottom. I'm going to put this bottom in parentheses so it'll divide this entire denominator into the numerator. So when I get my calculator, I'll have that number divided by, put in parentheses, 5.6 pi, and close my parentheses. When I push enter, I end up with 8.5. So my height is 8.5 millimeters. Okay, here is independent practice number 1. I want you to work that problem, and then I'll start working through it in 5 minutes. Okay, this is a right rectangular prism. The prism formula that we were referencing was 2b plus ph, where the b is going to be the area of the base, which this one, it's a rectangular prism, so all the sides are rectangles, so it doesn't matter which side you pick. So I'm going to actually pick the one that it's sitting on, and I'm going to say that this is my base, so it's 11. That'll be my length, or actually my base times height, which the 11 will be my b, and the 4 will be my h, which I'm used to calling that length times width. So to figure out the capital B, this will be 2 times the little b h plus ph. So the little b is going to be 11, the h is going to be 4. That means the capital B is 44. So if I take it over to my formula, I'll have 2 times 44 plus now the p. The p is the perimeter of the base. So I have 11 by 4 by 11 by 4. So that is how much? 11 plus 11 plus 4 plus 4. That gives me a total of 30 for my perimeter. So in my formula, I'm going to have 30 times the height, which is the number 5. Put it all together. 2 times 44 plus 30 times 5 gives me an answer of 238 feet squared is my surface area. If you got that correct, give yourself a check mark. Big old check mark. Alright, here is number 2. I'll give you 5 minutes to work this one. Okay, on this one, this is a cylinder, so my formula that I'm using is 2 pi r squared plus 2 pi r h. If I look at my problem, it says the height is 9 and the radius is 6, so that fills in my r and my h. So I'm going to substitute it in. 2 pi times 6 squared plus 2 pi times 6 times 9. I'm going to go straight to my calculator and type that in. Okay, putting it, whoops, I got an E. Dang it. Okay, okay, there we go. I'll get the right numbers. And I push equals, and I have my answer, 565 point, and I also notice here it said 2 decimal places, so this would be 49 centimeters squared. That would be my answer. So if you got this one correct, give yourself another check mark. Oops, that's a funny looking one. Okay, here we go with number 3, last one. I'll give you 5 minutes to calculate this and see if you get it correct. Okay, on this one we're dealing with a cylinder, so the formula that I'm going to reference is 2 pi r squared plus 2 pi r h. Okay, we're looking for the radius, so the r's will stay as they are. The height, they tell you, is 5 inches, and then they tell you that the surface area is 168 pi's. So I'm going to replace that in the front location. So it equals 2 pi r squared plus 2 pi r, and then I have the 5 for the h. Alright, now this one is a more difficult problem because we have 2 r's in this problem. I am going to go ahead and simplify this one first so that I can kind of see what's going on. So I'm still going to have the 168 pi equals this 2 pi r squared plus, and 5 times 2 is now 10 pi r. Okay, to solve it, I notice that I have a pi in both of my terms, so I'm going to pull out the pi. It's by factoring. And when I have pulled it out, I can then divide by pi and divide by pi, and those guys are gone, so that I just have 168 equals 2 pi squared plus 10r. I'm sorry, 2r squared plus 10r. Now, I need to move the 168 back over to the right hand side, and the reason is because I have a square term. That means it's quadratic. So if I move it back over to the other side, that means it goes from a positive 168 to a negative 168. So this is actually 2r squared plus 10r minus 168. And this will actually equal 0. One step I can do is, I notice that these are all even, so I can reduce everything by 2 to make this look a little nicer. And that will give me, let me write it down here on the bottom, r squared plus 5r minus 84. But this is still a problem. So what I'm going to do is I'm going to plug this into my calculator into the y equals, and I'm going to graph this picture. Now the r's will be x's and not r's. Okay, so that I have this. I'm going to graph it. And I want to see what it is, so I'm going to zoom out a little bit so I can see my picture. Okay, so I can see that it's going down and coming back up. Now my answers will be the x-intercept. So I have one at the left and I have one on the right. Now we're dealing with real life infants here. It's an actual cylinder. It's not an imaginary world. Therefore, I'm not going to worry about the left-hand side. That's a negative answer. I don't care about that. I'm worried about the right hand side. That number right there is what I'm looking for. So I'm going to move my cursor closer to that area, and then I'm going to zoom in and enter so that I can see that it's going through that point right there. That's the point I need to know what it is. I'm going to move my cursor over to that point, and I'm on it right there, even though my numbers looks funny, but this one tells me that basically my answer is a 7. So my radius will equal 7 inches. And this is the only reason I had to do this with when I'm looking for the radius. This is very, very important. looking for radius, because you will either have to factor this or graph it to find your answer for this problem.